Today we will review over how to approach balancing chemical equations. We balance chemical equations due to the law of conservation of energy. This law says that matter cannot be created or destroyed, but it can change form. In other words, whatever we have as reactants, we must have the same number of those elements as our products. The elements can rearrange. For example, here we have sodium and hydroxide. Over here we have sodium with bromine. The main point is that however many sodiums we have on this side of the equation, we must have the same number on this side of the equation. One of the things we must be aware of when we approach balancing chemical equations is that we cannot change our subscript. By changing the subscript, we have changed the chemical formula, and therefore it is no longer the correct chemical. Therefore, for us to prevent changing subscripts, as you approach doing your homework and balancing your equation, first write your equation on the paper. After you've written your equation on the paper, the next thing I want you to do is that I want you to add a box in front of each of the chemicals. Now where you've added the box is the only place that we can add any kind of numbers. So we've added our boxes. That's the only place we're going to add numbers to balance the equation. And now what we're going to do is we're going to count and find out exactly where we're at as far as balancing. We have sodium right here. We have one sodium. We have one sodium on this side. We've written this down. We have one hydroxide on this side. We have one hydroxide, or two hydroxides on this side. So we've written that down. 1 and 2. We have one calcium here. We have one calcium here. So we write this down. We have two bromines here. We have one bromine here. We've written that down. So as we look at our equations, our hydroxides are not balanced and our bromines are not balanced. So we need to add numbers in our boxes so that we can balance out all of our elements. So let's start off with balancing our equation. Let's start off with our hydroxides. Now remember that we had one hydroxide here. We have two hydroxides there. The only place that we're going to be allowed to draw any kind of numbers is going to be right here where we've got those boxes. And we're just kind of putting those back right in there, just like we had on the previous slide. And that's the only place that we're going to be allowed to add numbers. So those are our coefficients. Any numbers we add in each of these places is called coefficients. So how can we make these hydroxides equal? Remembering we have one here and two here. Well, if we put a 2 in this box right here, we'll follow that down. We now have 2 times 1, or we have 2 hydroxides. Remember we have 2 hydroxides here. But just in math, whatever I do to my hydroxides, I also do to my sodiums. So I have 2 times 1 for my sodiums, so I now have 2 sodiums. That means that my sodiums are now not balanced. So now, how can we balance our sodiums and our bromines? Remember, this was our equation we had right here, and we had added the 2 so that our hydroxides were balanced. Notice that we have 2 bromines on this side and we have 2 sodiums on this side. So if we put a 2 right here, 2 times 1 we have 2 sodiums, 2 times 1 we have 2 bromines. So let's check and see if we're balanced. We have 2 sodiums here, 2 sodiums here. We have 2 hydroxides here, 2 hydroxides here. We have 1 calcium, 1 calcium. 2 bromine, 2 times 1, 2 bromine. Therefore, we are now balanced. One additional thing I would like to tell you is that as you continue to balance and you get more practice, the balancing the equations becomes much easier. And so we start off by having you put boxes here and here and here and here to try to prevent us from making mistakes of changing our subscript. But as you become more comfortable with balancing equations, you can drop the boxes and just add the coefficient numbers as needed. And as you get used to balancing the equations, determining what coefficients go where in the equations becomes much easier. So, as we look at this slide, you'll notice that right here we have a balanced equation, and this is what we'll look for when you balance your equations. I'm not looking at the material that you're checking with, that's just to help you balance your equation, but I'm looking at, did you put the correct coefficients? Are your chemical formulas written correctly? Did you change any of your subscripts? You should not have. In a chemical equation, if you have a polyatomic, did you use the parentheses where you should have? If you have a diatomic, did you write it as a diatomic? But in this particular example, we are balanced. Well, let's try one more problem. Now we're going to try this equation right here, where we have ammonium hydroxide plus iron 3 chloride yields iron 3 hydroxide plus ammonium chloride. We're going to recognize one thing. Notice that we have NH4 on this side, and we have NH4 on our product side. Now, instead of counting and breaking up how many nitrogens do I have, how many hydrogens do I have, how many oxygens, chlorines, and irons and such, anytime we can find those polyatomics or those structures from Fat Daddy, and we find it on both sides of our equation, we're going to use that to our advantage. So on our reactant side, we have 1 NH4, and on our product side we have 1 NH4, and we're going to record it right there. We have 1 hydroxide here, we have 3 hydroxides here, so we're going to record those. 1 iron on this side, 1 iron on this side, and they're recorded. 3 chlorines, 1 chlorine. So now we can look at our information and see that our hydroxides and our chlorines are not balanced. Okay, now let's go ahead and finish up and see if we can balance the equations. As we look at it, we'll notice that we have the 3 hydroxides on our product side. So if we come in here and we write a 3, we'll have 3 times 1, and we'll have 3 hydroxides on our reactant side. Now notice that also now gives us 3 NH4s. So if I go to my product side, or the right side, and I add a 3, then what we end up with is, as we look at our equation, we have 3 NH4s here, 3 NH4s here, 3 OHs, 3 OHs, 1 iron, 1 iron, 3 chlorines, 3 times 1 are 3 chlorines. So we have finished this, and it is balanced. And this is what our balanced equation would look like. Here we have 4 sample problems for you to practice balancing. The next slide will have the answers, so you can pause this video, practice balancing these, and then check to see how well you're doing. Keep in mind as you do these, look for these polyatomics and see if they appear on each side. It'll make life much easier for you. So good luck, and we'll see how you do in just a moment. Well, hopefully you did well on balancing these 4 examples. Did one give you any difficulty? Many times you'll be given an equation to check to determine if it's balanced or not. And as you notice when you check that, yes, equation 1 was already balanced. And when you run across these, just write the word balanced and move on to the next equations. If you had any difficulty, stop by my classroom and we'll spend a little bit of time and see where you're struggling. And we'll just fix it and make it a piece of cake. Good luck, and we'll see you later.